you probably need some, sorry about that. All right, now you should be able to use the chat box. How you doing this afternoon, Caleb? I am doing well. It's kind of crazy how it's been quite some time since we've met. All right, let's get going. The last time, well, it wasn't even the last time we met because that was just a recorded thing, but it was trying to evaluate integrals that have that are going to like infinity. Did you have any troubles with these types of problems, Caleb? Good afternoon, Henry. How are you doing? Okay, so let's just go through an example here. This problem is the integral from 1 to infinity. So it's always good to know what the graph looks like on these types of problems. So I just made a real quick sketch of this thing, and it kind of looks something like this. Graph comes down, goes like this, okay? So we're going from 1 to infinity, okay? So we're going to go out here. And a lot of people think that the area should just be infinity because it just goes on and on and on and on. But that's not the case in most of these problems. In some of them, it is the case. So in a problem like this, what we do is we rewrite it as the limit as b goes to infinity, and then we do the integral from 1 to b, okay? And that's 1 over x to the third. I need to take the integral of this thing, so I'm just going to rewrite it as x to negative third. If I take the integral of this, remember when we take an integral, we add 1. So what is this going to be? X to negative second over negative 2. And that is still the limit, oops, as b goes to infinity. All right? And then if I work this out, it's going to end up, well, I could put this thing down. Let's rewrite this as the limit as b goes to infinity. Let's put that, so 1 over negative 2 to the x squared on the interval from 1 to b. So if I plug in b, this is just going to be 1 over negative 2 b squared minus, and then if I put in 1 over negative 2 times 1 squared, which is just 1. This function here is just going to be 0, isn't it? If it's the limit as b goes to infinity, if I put infinity down here, I go to small number over a big number, that's 0. Minus 1 over negative 2, so 1/2. If I did everything right, I think I did. And that is how you find an integral if you have infinity, or if there is an asymptote in your problem. All right. This one is for you guys. I want you to evaluate the integral from 1 to infinity of 6 over x to the fourth and see what you come up with. Okay. What would you get there? I think I did my problem wrong, so I better redo it. Yeah, I think I took a derivative instead of an integral. That's not good. Yeah, I definitely get a different answer than I had before. 6/5, 1/2. Man, am I doing something really wrong here? All right, let's let's try this. I came up with 2 for my answer. Um, I did have 6/5 the first time I did it, Henry, but I think I did it wrong. No. All right, let's do this problem and see if I I've just gotten over the flu, so maybe I'm just not thinking of these types of problems right. Okay, so I'm gonna take the integral of 6 over x to the 4th because that's the first thing I need to do. So I'm just gonna rewrite that as 6x to the negative 4th, right? But when we take an integral, don't we add 1 to our exponent? When we take a derivative, we subtract 1. So if I take the integral of this, isn't it 6x to the negative 3rd over negative 3? Yeah. Isn't that the integral? All right. So if I rewrite this, 6 over negative 3, that's really negative 2, isn't it? And then I'm just going to bring my x to the negative 3 down to x to the 3rd. So now I'm on the interval from 1 to b. Now, I really could put infinity in there if I wanted to. 2 is your new answer? Okay. So then if I, so this is going to be negative 2 over b to the 3rd minus, and then negative 2 over 1 to the 3rd, which is just 1. This becomes 0 minus or plus 2. So I came up with 2 for an answer. So I'm hoping that is correct. I know when you start messing with integrals and derivatives, we always want to add 1 or subtract 1 from the exponents. You always gotta be real careful. And today is no different because we're going to do separation of variables, and you have to take an integral of both sides. And I will tell you that I did a couple of examples for today, and I did not get the right answers. And I'm looking at it, and I'm like, what is going on here? And it's like, man, I was taking derivatives instead of integrals. So it happens to the best of us. All right. Last week, you were all supposed to be, you should have also been doing slope fields, okay? Now, today, what we're going to be doing is we're going to be finding the y prime here. We're going to be doing what is called separation of variables. It is one of the problems that is usually on an AP test someplace. So if I wanted to find the slope field here, it really is a pain when you think about it. I have to find all of the values for all of these points. Well, man, there's like 12 points here. So I've got -1, -1. I've got -1, 0. I've got -1, 1. I've got -1, 2. I've got 0, -1, 0, 0, 0, 1, 0, 2. I also have 1, -1, 1, 0, 1, 1, 1, 2. And I would definitely write it out just like this if I'm trying to find the slope field of a problem. Okay, so then I just have to plug it into, because what I'm really trying to do is I'm just trying to find the slope of at each point. So if I put -1 in here for x, that gives me -2 plus -1, so that would be -3. So at -1, -1, I have -3 slope. So I just make a little, and obviously I don't know if this is really -3 or not. I just, you're just estimating. And if I put -1 in here and 0 in for y, so that would give me -2 plus 0. So that's -2 slope. So it's a little less. And then if I put -1, 1 in here, -2 plus 1, that gives me -1. So now I have a -1 slope. And then if I put -1, 2, that's just going to be 0. So now I have a 0 slope. And that's all you do with slope fields. You just find the slope, and you just draw a tiny little line with that slope in there. So if I had 0, -1 here, that would be -1. 0, 0 would give me 0. 0, 1 would give me 1. 0, 2 would give me 2. So that's -1, 0, 1, oops, 1, and 2. And then if I finish this off, that's going to be 2 minus 1, which would be 1. That would be 2 plus 0, which would be 2. This would be 3, and this would be 4. So I have a slope of 1, then a slope of 2, then a slope of 3, then a slope of 4. So that would be my slope field. Slope fields, not too many people get slope fields incorrect. It's the other part of those types of AP questions is when they ask you to find the separation of variables. That's when it gets a little bit more complicated. All right, so today or this week, all we're doing is separation of variables, just one section. Pretty easy stuff, I think. When we're finding, so basically we did slope fields already. So we're going to be doing the separation of variables this week. When you find separation of variables, what you're going to do is you're going to be given a problem that looks like this. dy dx is equal to fy gx. So it's going to give you two functions. What you're going to do is you're going to rewrite it. You're going to separate it. You're going to put the y's on one side, and you're going to put the x's on the other side. And then you're going to anti-differentiate both sides. Usually when they have problems like this, they'll give you a c value, so you can find the exact equation. So an example of what they're going to be asking you to do is something like this. It says solve by separation of variables, and it tells us that y is equal to 3 when x equals 0. And this is in the original equation. So what we're really trying to do is we're really trying to come up with the original equation, right? That's what separation of variables helps us do. It helps us come up with the equation y is equal to. That's what we're looking for. At the very end, we want to have, we'll put it way down here, we want to have y is equal to something. Okay? So the first thing we want to do is we want to get the y's on the dy y on one side and the dx x on the other side. Okay, so that's not a problem. So I'm just going to bring the y squared. So this is going to be dy over y squared is equal to x squared dx. Okay, so step one, you get the y's on one side, you get the x's on the other side. Step two, we take the integral of both sides. So I'm going to take the integral of this side, I'm going to take the integral of this side. Now, in this side, I'm going to rewrite this as y to the negative second dy. And on this side, it's not a big deal because I already have x squared dx. Okay, so now I want to take the integral of both sides. Okay, well, the integral of y to the negative second, isn't that y to the negative 1 over negative 1? Which I could just put a negative in front, right? It makes no difference. So really, it's negative 1 over y is equal to, and then here I'm going to have x to the third over 3. I'm going to put that down here, x to the third over 3 plus c. All right, so this is my antiderivative, okay? I'm going to try to solve for y. That's what I want, right? First thing I have to do, though, after I take the integral, sorry about that. Just as I said, I'm just getting over a cold right now. I want to solve for c. So I'm going to plug. I know what my x value is. I know what my y value is. I need to solve for c. Now this is where some people make their mistakes. They don't solve for c fast enough. They kind of do some work on the problem, and it really messes things up. So my suggestion is, as soon as you take the antiderivative, plug in your x and y values and solve for c. So if I plug it in, so my y value, so this is going to be 1 over 3 is equal to, and I'm going to put 0 in for x, well, 0 to the third over 3, that's 0, plus c. Oh, look at that. I already know what my c value is. It's negative 1/3. All right, so I'm going to rewrite this as negative 1 over y is equal to x to the third over 3 plus or minus 1/3. Here's where a lot of math has to come into play, because what did I say when we started? I want to rewrite this as y is equal to. Look at this mess. How do I get that to be y is equal to? Well, there's kind of a really cool rule that says if you have, let's say I had 1/2 is equal to 5/10. This is a true statement, isn't it? Okay, I've got a fraction on one side, I've got a fraction on the other side. If I flip both of those, so I have 2/1 is equal to 10/5. Is it still true? And the answer to that question is absolutely. So that's the kind of trick I'm going to use down here. I'm going to, since my denominator is the same, it's 3, I'm going to rewrite this as -1/y is equal to x to the third minus 1/3. Okay, all I did is I just combined these two terms. And now I'm going to flip it. I've got y over -1 is equal to 3 over x to the third minus 1. I've got that -1 on the bottom, so I'm just going to put it up here and say, hey, I'm done. Y is equal to -3 over x to the third minus 1. That is called separation of variables. We're taking a derivative and we're rewriting it as the original equation. So this is the original equation. Any questions on that? I kind of like these types of problems. It puts a lot of stuff together. A lot of algebra. There's no question about it. I don't see any questions coming in. All right. I think I have the, oops, I don't have the answer key. All right. This is, I believe, 2 or 3 years ago. This is an AP question. Okay? It gives you, okay, so basically when they give you a problem like this, they'll want you to do the slope field, and then they'll ask you some other questions. I don't want to spend time on the slope field. Okay, it's a pretty easy thing to do. Most kids don't struggle with slope fields. It's these two problems down here, B and C. Those are the ones that cause some problems. So let's take a look at it. It says, consider the differential equation dy dx is equal to -x y squared over 2. Let y equal f of x be a particular solution to this differential equation with the initial condition f of -1 is equal to 2. And then they ask you to do the slope field. We're not going to do that. We're going to do this part. It says, write an equation for the tangent line to the graph of f at x equals -1. All right, please write an equation of a tangent line to the graph of f at x equals -1. Okay, I'm going to give you a couple seconds to work on that. I'll give you a little more in a couple seconds. I'll give you a couple minutes to work on that. See what you get. Okay, and then I'm going to go through my thought process on a problem like this. Caleb, can you try your microphone? I just want to see if the mic is coming through today.
There, is it working?
All right, I see your mic is on, but I don't hear anything. I'm going to jump out real quick as you guys are working on this, and then I'm going to jump back in, see if the mic works. Okay, 1 second. All right, Caleb, can you give it a shot, one more shot, see if the mic works now?
Can you hear me?
I can hear you. Awesome. All right. Much easier to talk to you guys than writing down on the board. All right. Do either of you guys have an equation for the tangent line there?
Yes, I think so.
All right, give it to me.
Okay, y equals
Wait, wait, wait,
2x.
wait, wait.
Oh,
Wait. Okay, go ahead. Y is equal to,
2x plus 4.
okay. Did it say write your equation in slope-intercept form? No
Oh,
question. Then why did you?
I don't know. That's what I'm most used to. Could I have used point slope form?
Yes. And when you're writing an equation of a tangent line, you really should be using point slope form because, and let me just show you why. Okay, in order to write an equation of a tangent line, what two pieces of information do we need? We need a point and we need slope, right? Well, in this problem, they gave us the point, -1. We know that the point has to be -1 too. They gave it to us. We do not know the slope, but heck, they gave us the derivative. So if I just plug -1, 2 in here, so -1 times -1, so that's 1. 2 squared is 4 over 2, so my slope is 2, okay? So there is my point, there is my slope. I'm gonna write my equation. Y minus 2 is equal to 2x plus 1. Now, yes, your equation is correct, okay? Y is equal to 2x plus 4, absolutely correct, because if I rewrote this, I would end up with 2x plus 2, and then I would add 2 to both sides. I'd end up with y is equal to 2x plus 4. No need to do that, though, on an AP test. Point-slope form is just as good as slope-intercept form. You can write it any way you want. I always just leave it this way because it's much quicker, and I'm not going to make any silly mistakes rewriting it. Okay, but it's up to you. I mean, if you want to write it in slope-intercept form, it doesn't tell us which form to write it in. You can write it in either one. But I always think point-slope form is much quicker. All right, so that problem, pretty easy, right? Part B, not a problem. Part C, though, that's where you have to use separation of variables. In part C, it says find the solution y is equal to f of x. So basically, they're asking us, hey, write the equation as y is equal to. All right, so I'm just going to erase all this stuff so I have more room to write. So I've got dy dx. Oops, I better turn my marker back on. So I've got dy dx is equal to negative x y squared over 2. Again, I'm just going to rewrite it with the y's on one side, the x's on the other side. So I've got dy over y squared is equal to, what is that going to be, negative 1/2 x dx. Okay, now I could have left it as negative x over 2. It makes no difference. So now I'm going to take the integral of both sides. Well, this y squared goes up to top, so that's really y to the negative second. Dy is equal to negative 1/2 x dx. Take the integral, so that's going to be y to the negative 1 over negative 1 is equal to, let's see here, so that's a 1 here, so I'm going to add 1, so that's a 2. So that's going to be negative x squared over 4, if I'm not mistaken, plus c. Okay, do you guys agree? Was that the correct integral there? Because now I am going to solve for c. And that's where a lot of students, they try to do so much extra work. Now I might change this. I might just put this as negative 1 over y is equal to negative x squared over 4 plus c. And then I'm going to plug in my x value and my y value. So let's see here. So that y value is 2. So that's going to be negative 1/4. Oh no, that was to the first power. Sorry about that. It's negative 1/2 is equal to, and if I put 2 in here, 2 squared is 4, so that's negative 4 over 4 plus c, so that's negative 1/2 is equal to negative 1 plus c. I'm going to add 1 to both sides. So c is equal to 1/2. I believe that's the hardest part of the problem, is trying to find your c value. So now I have my c value. I've got negative 1 over y is equal to negative x squared over 4 plus 1/2. Oh, again, we want to write it as y is equal to, so again, I'm going to use that little trick where I flip this. So I'm going to make this 2/4 here. So I'm going to rewrite this as negative 1 over y is equal to negative x squared plus 2 over 4. Flip it. So y over negative 1 is equal to 4 over negative x squared plus 2. Bring that negative 1 up here, so that just makes that a negative 4. So my answer would be y is equal to negative 4 over negative x squared plus 2. Now I believe, now this is a whole AP question, okay? Caleb, you took the AP test last year, correct? Henry, did you take the AP test last year? Okay, so what you're going to do, you're going to get 6 free response questions. I believe last year there was a free response question dealing with slope fields and separation of variables, okay? And the closer we get to the end of the semester, we'll be doing more and more of these free response questions. But here is what the answer key looks like. Caleb, do you remember how many points each problem is worth? How many points is each free response question worth? There's 6 of them, and they're all worth the same thing. No, they're all worth 9 points. And remember last year, I stressed that you're not going to get 9 points on every problem. If you average 5 points on each free response question, you will get a 5 on the AP test. That's just how it works, okay? So you're not going to get all 9 points. Now this problem here, I would think, well, I might shoot for all 9 points because this is in my ball game. I can do that. So let's take a look at how many points I would have gotten. Now, obviously I did not do the slope field, but I'm going to give myself the 2 points for the slope field because I think I could have gotten it. So 2 points, just 2 points, just for coming up with a slope field. Easy peasy. Now, part B was trying to come up with the equation for that line. Oh man, we only got 1 point for that? Okay, so we're at 3 points right now. We're at 3 points. We need 2 more in order to, as I think of it, is break even. So you get 1 point just to separate the variables. 1 point just to do that. 2 points to take the antiderivative. Oh, that's easy peasy. So now we're up to like 6 points already. Another point to find our C value. Uh-oh. What did I come up with our C value? Did I? Now, the C value in this problem is negative 1/4, okay? However, if you took a look at the way I did the work, I came up with 1/2, didn't I? But take a look at the final answer. The final answer that we came up with is correct. It is the 4 on the bottom. They must have did a little bit of work here before they found their C value. That's what I always say is, I always try to put my value in right away, but my answer is correct at the very end. So I would have gotten, booyah, I would have gotten all 9 points on this one. All right, time for you guys to try one. Here's a problem. It says, consider the differential equation dy dx is equal to 3x squared e to the 2y. Find a solution y is equal to f of x to the differential equation satisfying f of 0 is equal to 1/2. Okay, so that means we got to write our equation. I don't care about part B. It makes no difference to me, but I want you to use separation of variables. I want you to find the answer there. Okay, so I'm going to turn off my mic. I'm going to let you guys work, see what you get for an answer. All right. Have either of you guys come up with the C value?
Yeah, but mine seems kind of rough.
What'd you get?
1/2 e to the first.
1/2 e to the, and now Henry's got negative 1/2 e to the second. Let's check it out. All right. If I was going to do this problem, first thing I'm going to do is I'm going to put e to the, so I've got e to 2y dy is equal to 3x squared dx. Okay, I'm going to take the integral of both sides now. Well, the integral of e to 2y, isn't that e to the 2y over 2? Is equal to, and I'm going to add one here.
Yeah,
So
I just realized I have written down 1/2 e, negative 1/2 e. So we got the same answer. I just
negative 1/2 e. Okay.
put the wrong thing down.
All right. So now I have to put a plus c here. I'm going to cross out these 3's here. So right now is when I would plug in my x value is 0, my y value is 1/2. So I'm just going to plug those in. So if I put 1/2 here, that's going to be e to 2 times 1/2. So that's going to be e to the first over 2 is equal to, I'm going to put 0 in for x. So that makes it really nice. So I ended up with c is equal to e over 2. Uh-oh, did I miss a negative sign? Let's see here. I'm not so sure I should have a negative sign.
I think you're right. I don't know. Henry has a negative, but
Oh, okay. All right. Yeah, I don't see where I would get a negative sign there. I don't see where that would come in. So I'm going to leave it as e to the e over 2. Okay. Henry, are you okay with e over 2? All right. So now I've got this mess. I've got e to the 2y over 2 is equal to x to the third plus e over 2. Now, what do I want my answer to be when I'm all done?
in terms of y,
Exactly. I have to rewrite this thing as y is equal to. All right. So now I'm not 100% sure that every student's algebra skills are as good as mine. If I was going to solve this problem, the first thing I probably would do is I would probably multiply through by 2, just to get that 2 out of there. Okay? So if I multiply through by 2, this is multiplied by 2. Get rid of that 2. So I have e to 2y is equal to, and if I multiply through here, I got 2e, or 2x to the third plus e. How do I get rid of this? How do I get this as y is equal to? How do you do that? Because you can't do that. You're gonna have a tough time with these types of problems. Okay? What math step can we do? Natural log. Very good. So we're going to take the natural log of both sides, right? And that's going to leave me with what? What is that going to leave me with? Well, now I'm gonna kind of go away from natural log just of right now. If I gave you something like this, if I said, okay, I've got 3 to the second power is equal to 9. Okay, let's just start with that. I know that I can rewrite an exponent as a logarithm, right? So 3 to the second is equal to 9. I could rewrite that as what? Okay, can we rewrite this as log base 3 of 9 is equal to 2? Is this the same thing as this? And that's where I'm going with this type of problem. So I'm going to rewrite this as the log base e of 2x to the third plus e is equal to 2y. Now, log base e That's really natural log. So now I've got the natural log of 2x to the third plus e is equal to 2y. Divide through by 2. I end up with y is equal to the natural log of 2x to the third plus e over 2. So a lot of algebra going into these types of problems, being able to, because I mean, this was not calculus, right? When you got to this point, when you wanted to rewrite it as y is equal to, that is not calculus. That is, you know, that I would say that's a little bit higher than algebra 2, maybe pre-calculus. I mean, we do cover this in algebra 2, being able to rewrite a logarithm as a, or an exponent as a logarithm as an exponent. We've done that, right? But kind of an interesting problem. And sometimes they'll even rewrite it even farther, okay? So if you take a look at what they have here, you know, they rewrote it, and look at it, 6 points for being able to get to that point where you've got 1/2 natural log of 2x to the third plus e. 6 points for doing that. Now, we didn't do part B, but those are types of problems. If you get a separation of variables on an AP test, those are types of problems where, you know, you're only looking for 5 points on each problem. If you can get more, awesome, because then you can bank your points. All right. Let's see, I don't know what kind of other problems we have here. Let's try this one. All right. This problem here, it says find the general solution. So when it says general solution, we don't have to find the C value anymore, okay? The C value, they don't give you they don't tell you what f of x is equal to, so you can't find it. But you should be able to come up with the general solution here, okay? So which one of these is correct? You get your answer, you can just blurt it out, A, B, C, D, or E. Henry says letter B. All right. So if I started working on this problem, I might just rewrite this as 8y squared dy is equal to 5x squared dx. I can take the integral now. So that's going to be y to the third over, 8y to the third over 3 is equal to 5x to the third over 3. Now, and I better put a plus c in there, okay? So now, if I want to start getting rid of things, I might multiply through by 3, and that's going to take care of that. Now, some kids are going to say, but Mr. Shanklin, you didn't divide the c by 3 or multiply the c by 3. You don't have to. C is a constant. Does it matter if it's c or if it's 3c? No, makes no difference. C is c. C is a constant. Doesn't matter if you multiply it or square it, it's still going to be a constant. So it really doesn't make any difference. So now I have 8y to the third is equal to 5x to the third plus c. I'm still trying to solve for y. So I'm going to divide through by 8 and then just take the third root. So I've got the third root of 5/8 x to the third plus c. Now, again, you don't have to put that 8 on the c because it's still going to be c. So that's why I would agree with letter B as the answer. Very nice. So separation of variables, fairly easy thing to do. Next week is exams. You have the whole week to do the exams. I believe I'm going to open up my exams on this Wednesday. So if you wanted to get started early on them, you absolutely can. My exam for AP Calc is set up very similar to the AP Calc exam at the end of the year, where it's 4 parts, 2 multiple choice parts and 2 free response questions. Any questions on anything? Anything that you guys have any questions on? If not, hey, how much snow did you guys get? Man, they were calling for like 9 to 11 inches down here. We got maybe 2.5 to 3. Yeah, exactly. Were they saying that you guys were going to get a lot more? No, I am so glad we did not get all that snow. I mean, I can deal with a couple inches. We're getting to the middle of January. Let's get this winter over. Get into springtime so I can get out and do some fishing. All right. You guys have a great rest of the semester, and hopefully we'll see you back second semester. Bye.